This article lists and discusses the usage and derivation of names of large numbers, together with their possible extensions. The following table lists those names of large numbers that are found in many English dictionaries, and thus have a special claim to being real words. The traditional British values shown are unused in American English and are becoming rare in British English, but their other language variants are dominant in many non-English speaking areas, including continental Europe and Spanish-speaking countries in Latin America. See long and short scales. English also has many words, such as zillion, used informally to mean large but unspecified amounts. See indefinite and fictitious numbers. Standard dictionary numbers. Apart from million, the words in this list ending with illion are all derived by adding prefixes by, try, etc., derived from Latin. To the stem illion, centillion appears to be the highest name ending in illion that is included in these dictionaries. Trigentillion, often cited as a word in discussions of names of large numbers, is not included in any of them, nor are any of the names that can easily be created by extending the naming pattern. Unvigentillion, duovigentillion, duoquinquagentillion, etc. All of the dictionaries included Google and Googleplex, generally crediting it to the Kastner and Newman book and to Kastner's nephew. None include any higher names in the Google family, Googlegplex, etc. The Oxford English Dictionary comments that Google and Googleplex are not informal mathematical usage of names of large numbers. Some names of large numbers, such as million, billion, and trillion, have real reference in human experience, and are encountered in many contexts. At times, the names of large numbers have been forced into common usage as a result of hyperinflation. The highest numerical value banknote ever printed was a note for 1 sextillion pengo. 1021 a 1 milliard bill pengo was printed in Hungary in 1946. In 2009, Zimbabwe printed a 100 trillion, 1014, Zimbabwean dollar note, which at the time of printing was worth about $30. Names of larger numbers, however, have a tenuous, artificial existence, rarely found outside definitions, lists, and discussions of the ways in which large numbers are named. Even well-established names like sextillion are rarely used, since in the context of science, including astronomy, where such large numbers often occur, they are nearly always written using scientific notation. In this notation, powers of 10 are expressed as 10 with a numeric superscript, e.g., the X-ray emission of the radio galaxy is 1.3 times 1045 joules. Quote, when a number such as 1045 needs to be referred to in words, it is simply read out as 10 to the 45th. This is just as easy to say, easier to understand, and less ambiguous than quatu or decillion, which means something different in the long scale and the short scale. When a number represents a quantity rather than a count, SI prefixes can be used. Thus femtosecond, not 1/40000th of a second, although often powers of 10 are used instead of some of the very high and very low prefixes. In some cases, specialized units are used, such as the astronomer's parsec and light year of the particle physicist's barn. Nevertheless, large numbers have an intellectual fascination and are of mathematical interest, and giving them names is one of the ways in which people try to conceptualize and understand them. One of the earliest examples of this is the sand reckoner, in which Archimedes gave a system for naming large numbers. To do this, he called the numbers up to a myriad, 108. First numbers, and called 108 itself the unit of the second numbers. Multiples of this unit then became the second numbers. Up to this unit taken a myriad times. 108 equals 1016. This became the unit of the third numbers, whose multiples were the third numbers, and so on. Archimedes continued naming numbers in this way up to a myriad times the unit of the 108th. Numbers i.e. 10, 8, 10, 8 equals 10, 8, 10, 8. Display style 10 caret 8 caret 10 caret 8 equals 10 caret 8 CDOT 10 caret 8. Closing curly bracket, and embedded this construction within another copy of itself to produce names for numbers up to 10, 8, 10, 8, 10, 8 equals 10, 8, 10, 16. Display style 10 caret 8 caret 10 caret 8. Closing curly bracket, caret 10 caret 8 equals 10 caret 8 CDOT 10 caret 16. Closing curly bracket. Archimedes then estimated the number of grains of sand that would be required to fill the known universe, and found that it was no more than 1,000 myriad of the eighth numbers. 1063. Since then, many others have engaged in the pursuit of conceptualizing and naming numbers that really have no existence outside the imagination. One motivation for such a pursuit is that attributed to the inventor of the word Google, who was certain that any finite number had to have a name. Another possible motivation is competition between students in computer programming courses, where a common exercise is that of writing a program to output numbers in the form of English words. Most names proposed for large numbers belong to systematic schemes which are extensible. Thus, many names for large numbers are simply the result of following a naming system to its logical conclusion, or extending it further. Origins of the standard dictionary numbers. The words bimillion and trimillion were first recorded in 1475 in a manuscript of Jehannadam. Subsequently, Nicolas Tuquet wrote a book Tripartie en la science des nombres which was not published during Tuquet's lifetime. However, most of it was copied by Estienne de la Rochefort, a portion of his 1520 book La Arithmétique. Tuquet's book contains a passage in which he shows a large number marked off in two groups of 6 digits, with the comment, Au qui vaut la première point peut signifier million, la second point billion, la tiers point trillion, la quart quadrillion, la cinque quillion, la sixillion, la sept septillion, la height octillion, la neuf nonillion et ainsi des autres chez plus alter en voloit. Procedure. Or if you prefer, the first mark can signify million, the second mark billion, the third mark trillion, the fourth quadrillion, the fifth quillion, the sixth sexillion, the seventh septillion, the eighth octillion, the ninth nonillion, and so on with others as far as you wish to go. Tuquet is sometimes credited with inventing the names million, billion, trillion, quadrillion, and so forth. But from the way in which Adam and Tuquet used the words, it can be inferred that they were recording usage rather than inventing it. One possibility is that words similar to billion and trillion were already in use and well known, but that Tuquet, an expert in exponentiation, extended the naming scheme and invented the names for the higher powers. Adam and Tuquet used the long scale of powers of a million. That is, Adam's bimillion, Tuquet's billion, denoted 1012, and Adam's trimillion, Tuquet's trillion, denoted 1018. The Google family. The names Google and Googleplex were invented by Edward Kastner's nephew, Milton Sirota, and introduced in Kastner and Newman's 1940 book, Mathematics and the Imagination. In the following passage, The name Google was invented by a child, Dr. Kastner's 9-year-old nephew, who was asked to think up a name for a very big number, namely one with 100 zeros after it. He was very certain that this number was not infinite, and therefore equally certain that it had to have a name. At the same time that he suggested Google, he gave a name for a still larger number, Googleplex. A Googleplex is much larger than a Google, but is still finite. As the inventor of the name was quick to point out, it was first suggested that a Googleplex should be 1, followed by writing zeros until you got tired. This is a description of what would actually happen if one actually tried to write a Googleplex. But different people get tired at different times, and it would never do to have Carnero a better mathematician than drive Einstein, simply because he had more endurance. The Googleplex is, then, a specific finite number, equal to 1 with a Google zeros after it. Conway and Guy have suggested that nplex be used as a name for 10n. This gives rise to the name Googleplex. Plex for 10 Googleplex equals 101,010,100. This number, 10 to the power of a Googleplex, is also known as a Googolgplex and Googleplexion. Conway and Guy have proposed that nminx be used as a name for 10-n, giving rise to the name Googominx for the reciprocal of a Googleplex. None of these names are in wide use, nor are any currently found in dictionaries. The names Google and Googleplex have inspired the name of the Internet company Google and its corporate headquarters, the Googleplex, respectively. Extensions of the standard dictionary numbers. This section illustrates several systems for naming large numbers, and shows how they can be extended past vigintillion. Traditional British usage assigned new names for each power of 1 million. The long scale, 1 million equals 1 million, 10 million and 2 equals 1 billion, 10 million and 3 equals 1 trillion, and so on. It was adapted from French usage, and is similar to the system that was documented or invented by Touquet. Traditional American usage, which was also adapted from French usage but at a later date. Canadian and modern British usage assign new names for each power of 1,000. The short scale. Thus, a billion is 1,000 times 10,000 and 2 equals 109. A trillion is 1,000 times 10,000 and 3 equals 1012. And so forth. Due to its dominance in the financial world, and by the US dollar, this was adopted for official United Nations documents. Traditional French usage has varied. In 1948, France, which had been using the short scale, reverted to the long scale. The term milliard is unambiguous and always means 109. It is almost never seen in American usage, rarely in British usage, and frequently in European usage. The term is sometimes attributed to French mathematician Jacques Pelletier du Mans circa 1550. For this reason, the long scale is also known as the Touquet-Pelletier system. But the Oxford English Dictionary states that the term derives from post-classical Latin term milliatum, which became millia and then milliot and finally our modern term. With regard to names ending in iliad for numbers 106 n plus 3, milliard is certainly in widespread use in languages other than English, but the degree of actual use of the larger terms is questionable. The terms milliard in German, Milliard in Dutch, Milyar in Turkish and in Russian are standard usage when discussing financial topics. For additional details, see billion and long and short scales. The naming procedure for large numbers is based on taking the number n occurring in 103 n plus 3, short scale, or 106 n, long scale, and concatenating Latin roots for its units, tens, and hundreds place. together with the suffix zillion. In this way, numbers up to 103,999 plus 3 equals 103,000. Short scale, or 106,999 equals 105,994. Long scale may be named. The choice of roots and the concatenation procedure is that of the standard dictionary numbers if n is 20 or smaller. For larger n, between 21 and 999, prefixes can be constructed based on a system described by John Horton Conway and Richard K. Guy. Caret when preceding a component marked S or X. Tray changes to tres and shay to ses or sex. Similarly, when preceding a component marked M or N, septe and nov change to septem and novem or septen and noven. Since the system of using Latin prefixes will become ambiguous for numbers with exponents of a size which the Romans rarely counted to, like 106,258. Conway and Guy have also proposed a consistent set of conventions which permit, in principle, the extension of this system to provide English names for any integer whatsoever. The following table shows number names generated by the system described by Conway and Guy for the short and long scales. Names of reciprocals of large numbers do not need to be listed here, because they are regularly formed by adding th, e.g., quatuordecillionth, centillionth, etc. Binary prefixes. The International System of Quantities, ISQ, defines a series of prefixes denoting integer powers of 1024 between 10,241 and 10,248. Proposals for new naming system. In 2001, Russ Rowlett, director of the Center for Mathematics and Science Education at the University of North Carolina at Chapel Hill, proposed that, to avoid confusion, the Latin-based short-scale and long-scale systems should be replaced by an unambiguous Greek-based system for naming large numbers that would be based on powers of 1,000. Other large numbers used in mathematics and physics: Avogadro's number, Graham's number, Skewer's number, Steinhaus-Moser notation. See also Robert Munafo's large numbers. Full list of large number names, lists sorted by 10n and by word length. Big Numbers educational site, which can name any numbers put into it, up to centillion. How High Can You Count? By Landon Kurt Knoll, which describes a slightly different system from the one here. The English name of a number, an online tool that prints names of numbers of any size. Using the system in the previous link.